Not that you've had a chance to, study stacks using either array-based or linked-based implementations. Let's look at stack variations. So these are alternatives that we can pursue in terms of implementing, a stack. So these are just an idea, okay? And there's definitely pros and cons, with every decisions that we make here. So let's just look at some of these alternatives. One of them is to use a stack of class objects. So what does that mean? Well, instead of passing in a generic type, letting you specify, hey, this stack is of type integer, the stack is of type string, you would instead use object. So this, there's also an issue with this is, right, if you were to treat every single object as a Java object, native object, when it comes to popping information off the stack, how do you know what this object is, right? Is it an integer, right? Is it a string, right? Is it a Boolean? You don't know, okay? This means that this stack would then also be loaded with the responsibility of keeping track of what those objects are, right? If you don't know what this object is. Or maybe you want to build something into the object, in this case, a user-defined type. And again, we talked about this, in the earlier chapter 2, right, where we can keep track of the object references in the stack instead of using a generic. Again, so this is not recommended, but is definitely one of the alternatives. In terms of our mutations, right? So this is the transformer we're talking about. As you know, pop operation is different than top operation. So top in our current implementation means peek, right? It's basically checking to see, or read only, right? Read only. Now we can implement a pop operation where a pop operation will be doing two things. One is to remove, right? And the other one is to return top elements. So you can do both. So instead of having both operation be in a separate methods, now you can combine both operations in one. There's also exception throwing. This is quite annoying sometimes, if you throws, right? This is a plural throw. This means that you're expecting to add this throw conditions to the method signature, expecting the invoking function to take care of those exceptions, capturing it. So that's a chore for the invocation methods, right, or invoker. Or you can throw the exceptions within the code, right? But that means whoever is invoking this function with the exceptions, that function would have to implement as well. So instead of doing that, you can specify this as a precondition and simply just build your pop based on a return type, using a return type as to indicate a result of the operation pop. So this Boolean can say success or not success, right? Not successful. So this would means that your pop is no longer going to be a void. It will be a public Boolean. Oops. Boolean, right? And pop. So that would be the method signatures there with the Boolean return type. So these are some of the ideas. There's more. Let's move on to the next page. So this is the Java Collection Framework stacks. And as you can see, there are several ideas. One is, why don't we make use of array class? So array is just vector class. So vector is just it's just an array, a concept of array. And the difference between this and in Java, array is actually called array list, right? So this is a data structure in Java. So vector is another data structure. Now, the difference between the two is, and this is similar to array, right? Conventional array that you see in C++ and Python. The difference between vector and array is vector is synchronized, meaning it is thread safe. Array list is not thread safe. It allows multiple threads from accessing the elements, but vector ensures that there's only one thread or worker having access to any elements inside the array at any given time. So you can ensure that the information inside the vector is synchronized, whereas information inside the array list, could be touched by multiple concurrent, threads. Anyway, so that is the details. But if you were to extend your stack, right, using either vectors or ArrayList. Both of these classes, you can go into the Java API. They come with some free utilities, right? The capacity, clear, clone, contains, is empty. And what is really cool is a vector also comes with a search operation. So yeah, you can make, you can basically inherit all of these methods from these existing classes if you were to inherit, right, your stack from it. So extend means inheritance, right? So you'll be getting all of these features, operations free of charge. But this comes with the runtimes, right? Costs, because inheritance is not that cheap, right? From memory consumption standpoint. So you'd be getting free operations at the expense of memory consumptions. But still, I mean, if your computer is fast, your server is fast, and there's not a lot of information that you have to do to keep track of them in a stack, then this is a viable options. So yes, so these are just a couple of ideas that you can do. If you go back to reviewing the linked stack and array-based stack, you can see that the author of the book, and this is in the code sections, right? The author of the books didn't do any of that, right? Everything is implemented using a Java generics from the ground up. There is no external import of any Java utilities or libraries. Okay, so let me know if you have other questions. So these are viable alternatives for how a stack could be implemented in Java.